Hello and welcome to what is probably going to be a very interesting and very controversial video on the Amendment 2 for BS7671, which is due to come out on the 28th of March this year. So Amendment 2 is huge, and I'll show you how big it is in a second. I'm surprised actually they've not just done edition 19, to be honest with you, with the amount of changes that have been done, or proposed I should say, because this is, although it's coming out in March this year, just 2 months away, these proposals may change, and I know there's still moves afoot to get one particular one altered. You'll see why in a minute. But what I'm going to do in this video is I'm just going to cover those areas that relate to domestic installations, and especially those that we're going to come across day in, day out. I'm not going to cover any of the commercial or industrial changes that have come up, or anything that we don't come up against, on a regular basis. Now, there's a lot to cover, so I'm probably not going to cover it all in this video. I'll probably make a second one to cover the rest. But in this video, we're going to cover the changes to the earthing arrangements, changing to fire protection, and the changes to initial verification, particularly to do with insulation resistance. A welcome change, I might add, and something that people have been wanting for a long time. So let's have a very quick overview of BS7671 Amendment 2. So here's Amendment 2 BS7671, and I'm just going to very quickly just scroll down this starting section, and you can see how much has been changed. All the way down here, and an entirely new Chapter 8, changes to the appendices as well. So there's a lot changed, but in this video, like I said, today we're going to cover Chapter 41. We're going to check on this one. Chapter 42, which is this one on AFDDs, and then finally we are going to do, if I can find it, I've lost it, Chapter 64 on initial verification and the change to the insulation resistance test. So let's go and have a look at a couple of little bits here on Chapter 41. Now, the main thing here is this one here, the regulation 411.3.3. Now, in the original BS7671, the section here that this relates to is this paragraph. It says additional protection by means of an RCD with a rated residual operating current not exceeding 32 milliamps shall be provided for socket outlets with a rated current not exceeding 32 amps, and so on. So what the new regulation is stating is the exception allowing RCD protection can be omitted where a documented risk assessment determines that RCD protection is not necessary has been removed. Basically, there are now no exceptions. An RCD has to be there. So you can't get away with just doing a risk assessment if you don't want to put an RCD in. No, you've got to put an RCD in now, or at least you will do. So that's the major bit there. That's the major change there. The other bit, which is actually a bit of common sense really, is the paragraph just slightly above that, and it's basically dealing with bonding incoming pipework such as gas pipes and water pipes. You're no longer going to need to bond the metallic part of that pipework if the pipework is plastic to start with, or rather non-conductive coming into the building. Yeah, it makes a lot of sense. That's just common sense, and you don't bond plastic. So that's alright, can't see a problem with that. Now, I'm going to skip over the AFDD one just for a second, and we're going to go down to a very welcome change indeed. And people have been calling for this for a long time, and it's this one. So, this bit here, the initial verification, which is Chapter 64, the requirements for testing insulation resistance where equipment is likely to influence the verification test or to be damaged have been clarified and reference made to a 250 volt test. In the original document, no such reference is made, and it's stated as 500. Before anybody says, oh no, it is mentioned, but only specifically fixed socket outlet incorporating an SPD. It makes no reference to things like USB charging sockets and LED lights and so on. It makes no reference to that whatsoever. Okay, so you can see on screen the new section here, and the bit that has changed is 64333. As you can see, this paragraph here has been altered. So now it said you can do a 250 volt DC test if the equipment has been connected. So before it's been connected, you can still do 500 volts. But if it's already been connected, then the test can be done at 250. This is a long time in coming, and I know a lot of people have been asking for this. It is practically impossible to do a 500 volt DC installation resistance test in a property that's already built and already has a live electrical system in it. So AFDDs, the big change that everybody's talking about in the electrical industry. So what does the new 42117 say? Well, as you can see, it says that AFDD devices shall be provided for single-phase AC final circuits supplying socket outlets and fixed current using equipment with a rated current not exceeding 32 amps. AFDDs may be omitted where unexpected disconnection of the circuit could cause danger. And if you look all the way down there to number 6, lighting circuits in dwellings. So what that actually means is that any circuit, any radial circuits or ring finals will need to have an AFDD, but lighting circuits and anything above 32 amps won't need them. So that means your shower circuits, your cooker circuits, even potentially your EV charging circuits won't need to be protected by an AFDD. So what does an AFDD look like? Well, it looks like one of these. Doesn't look any different from an MCB or an RCBO, does it? This one's from Wilex, but they're all doing them. And this particular one is a combined one, MCB, RCBO and AFDD. You can just get bog standard AFDDs, but you're probably more than likely going to see these becoming more and more prevalent, in the same way that dual RCD boards have fallen out of favour in favour of RCBOs. I think this is the common one you're going to see the most of. There's been a lot of consternation about this change, particularly because of it being mandated that they have to be put in for any new consumer boards as of March of next year, 2023. Why are they caused so much consternation? Well, it's not because of what they are. They're a really good idea, and the UK is way behind everybody else in the world. They've been used for years in the United States and in Europe, so we're just playing catch up. And for our US cousins, if anyone's watching, an AFDD is this. Okay, we just call it different. We're British. What do you expect? We don't conform. So if it's not the idea of these devices, why has it caused so much consternation? Well, simply put, it's their cost. An AFDD, which is combined with an RCBO, costs, at the time of this video being made, £150 or more. You compare that with the normal cost of an RCBO, which is about 25 quid, and an MCB about 5. You can see where the issues are coming in. The manufacturers are saying that they're not going to drop those prices because of supply and demand. So we've got a situation whereby a consumer board, box standard consumer board, will cost around 150 quid or thereabouts. A fully populated dual RCD board, let's just say, around 150 quid. That neck of the woods. A fully populated RCBO board, £300-400. If you were to put in a fully populated AFDD board, you're talking over £1,000, almost without question. Even with the fact that you don't have to put them in on lighting circuits and cooker circuits and so on. Even if you're putting it on maybe say 2 ring finals and a couple of radials, you're still talking well above £600. So, you know, we're going to get clients just basically turning down work. You could have a situation in, say, let's just, for argument's sake, let's say towards the end of February 2023, you go into a client site, it turns out that they need a new consumer board, you quote it as a bog standard consumer board, say we're fully populated RCPO board, let's just go for the argument's sake, 300-400 quid. That client comes back on the 29th of March after these take effect, saying they want to go ahead. You then turn around and say, well, sorry, but we've got to put these new AFDDs in. That £400 has now come £1,200. I know exactly what the client will say. They'll say, on your bike. So, these AFDDs, what are they and why are they now being mandated? Well, simply put, an AFDD is something called, it stands for an arc fault detection device. And I can see, whoa! People doing a little flyby. Let's quickly go over what type of things we've currently got in that consumer unit of ours. We've got MCBs, which deal with overload protection. We've got RCDs, which deal with earth fault protection. And now we're putting in arc fault detection devices. So what exactly are they protecting against? Okay, well, arcing is something we see every day. You'll see if you've got an overhead railway line nearby, you'll see arcing from the pantographs to the overhead lines. Lightning is another form of arcing. Arcing happens inside light switches or in motors such as hoovers and washing machines. It's there all the time. Static electricity. If you've got any static electricity, you touch something conductive, you'll see a spark. And obviously arc welders. Now, why do arc welders work so well? Well, that's because that little spark that you see can be up to 6,000 degrees centigrade. That's more than enough to melt metal. Now I think you're beginning to see why these arc fault detection devices are becoming important and are going to be mandatory. If you were to get arcing of sufficient intensity inside a consumer unit, it's very likely to melt it. And if it's plastic, almost certainly it will. And metal, it's possible. But the major problem is fire. So, in what situation could we get arcing? Well, one way would be if you put a screw through a cable. Worn cables, so exposing conductive parts, loose connections, all of those could actually cause arcing. Even a plug that's not plugged properly into a socket will cause arcing. So, how exactly does this AFDD do it? Well, I'm not going to go into the actual technical ways of doing it, but very simply, what it does. An AC current is a waveform, it's a sine wave. Okay? Now, any arcing will disrupt that sine wave. So, if you turn on a light switch or you're on a hoover, that sine wave is going to slightly wiggle. It's going to get slightly disrupted. Now, an AFDD won't trip if it's detecting that kind of thing. So, it's designed to detect major changes in that sine wave, major disruptions where it's probably doing that. That will detect an arc and it will trip. Now, I'm not going to tell you where that trip is, and you're still going to try and go out and look for it, but it will trip out. Now, just like with type AC RCDs, that could be blinded by DC leakage currents, AFDDs aren't infallible. There are certain circumstances where they won't detect an arc fault, or they won't work as they're designed to. And the one circuit where they won't work as designed is in ring final circuits. This is a unique situation to the UK, as we're one of the very few countries left that use ring final circuits. And the reason is there are two types of arcing. There's something called serial arcing and something called parallel arcing. Now this picture here shows an example of serial arcing. Effectively that's arcing in one conductor. That one conductor's got broken or damaged, and the arcing, that conductor's simply got broken and it's arcing in that conductor. Parallel arcing, which is this one, is basically arcing between conductors. So that's between your line and your neutral, your line and your earth. An AFDD will not detect a serial arc fault, i.e. an arc fault in a single conductor in a ring final. And simply put, it's because it doesn't exist. If you've got a fault in a ring final, something like that, what happens to it? It becomes two radials. An arc doesn't occur, so it can't detect that. So a break in a ring final will still go undetected. It won't be seen by anybody until you run do an EICR, you do your normal tests, continuity tests on your ring final, and you don't get any continuity. Only then will you find it. However, the AFDD will trip if you see if it sees arcing between conductors. Now, it's fair to say that very likely when that happens anyway, almost certainly the RCD will trip, because if it's between the line and the earth, that's an earth fault, and the RCD will trip out anyway, so it will be tripped. But this is a unique situation to ring finals, so AFDDs really aren't that much use in ring finals, really, because the RCDs will protect it if it's an earth fault. I suppose you could argue that the AFDD will protect you if it's a line to neutral fault. It's arcing between those two, yeah, maybe. But these AFDDs are really designed for radial circuits, so radial socket circuits, but as I pointed out in BS7671, they don't need to be put in on lighting circuits. It's only socket circuits really that these need to be put in on. Anything else doesn't need to be. Now, to me that doesn't seem to make a lot of sense, because if you've got a really high load circuit like a cooker circuit, surely that's where you would want an AFDD. But according to the new regulations, you don't. But even so, this is going to increase the costs to the client. We're not going to see these extra costs. This is a material cost. This is a cost that the client is going to have to shoulder. We won't see any of that. These prices and the profits are going to be lining the manufacturer's pockets, not us. A lot of electricians have said that this change to regulations just isn't viable, it isn't workable, and I'm one of them. I don't think it's workable, because simply put, it's designed to make installations safer. I can see what they're getting up to here, and that's fine. But a client isn't going to pay for these changes, not at £150 per unit. They're not going to pay it, therefore it's not going to go in. So I've seen a lot of people saying that there's three options for the IET here. Either they scrap this change and leave it as it is, they get rid of it altogether, or they put some pressure on the manufacturers to bring these prices down. So I don't know what will happen between now and March. Like I say, these regulations aren't yet set in stone. It's very close. The concrete's been poured. Let's put it that way, if you want an analogy. But I hope something happens to it. I think it has been changed a little bit from the first draft I saw some time ago. I think it mandated every single circuit at one point. So it has been changed to bring it down to that. But that seems to be like a bit of a fudge. And it's this part of the changes that I think are going to cause so much consternation. If this is delayed in any way coming out, and yet they're still saying these changes have got to be mandatory in March of 2023, we're going to lose business hand over fist here. I can see it coming, really can. So on a personal basis, I'm pleading with the IET, do something with this particular regulation before you publish it. Please get these prices down, because otherwise, as well-meaning as that regulation is, it just won't happen. Our clients, I know my clients certainly won't pay that. They're not going to pay £600-700 for a new board. That ain't going to happen. So we're going to be left with situations where boards are going to go unchanged and so on. I don't know what will happen if I have to fail a board in an EICR and I land a client with a £1,000 bill. Yeah, that'll be interesting. So anyway, that's it for part one. I'm going to do another part with some of the other regulation changes. They're not all daft and bad. Some of them are actually pretty good. Like I say, the insulation resistance one, that's well overdue and it's brilliant. That'll make doing insulation resistance testing on the ICRs and things like this a lot simpler. It means you can do them without a problem. So anyway, I'm really looking forward to the comments on this one, because I'm pretty sure there are going to be loads of people making comments about these AFDDs, because I know that, you know, it's caused a lot of comment, shall we say. That's a polite way to put it. So anyway, I think that's it for this video. So I will see you on the next one.